Okay, we are recording, so I'm just going to put the share the right screen. I've got a few slides to show in this particular session of training. So let's start with the correct slides. We're looking at the MPEG transport stream. Last week we looked at the IP layer and how best to monitor things like multicasts and of course unicasts for metrics like IP jitter, bandwidth and media loss rate. But of course we mustn't forget that inside each of those IP packets is usually 7 MPEG transport stream packets. And those transport stream packets also have tests that can be done on them. IP testing can only show us so much. If we want to then look inside the MPEG transport stream and see how the behavior of the MPEG transport stream is, then we need to do something else. We can't use the IP testing, so we use ETR testing. Now, ETR testing's been around for a long time. 1993, in fact, was when it was first introduced by ETSI. Before 1993, where digital television was really sort of hitting its stride, manufacturers were making encoders, they were making multiplexers, they were making set-top boxes, and they were making professional IRDs. And sometimes the interoperability wasn't very good, and one manufacturer's encoder couldn't be decoded by another manufacturer's IRD. This caused problems because the IRD manufacturer said, well, we're compliant, and the encoder manufacturer said, well, we're compliant. So who knew where the problem lay? So, of course, everyone blamed everyone else. That's the way. That's how these things work. So the ETSI Standards Board produced ETSI TR 101-290, and Bridgetech, along with many other people, shorten this to ETR 290. Sometimes you'll see it ETR 101-290. It's all the same thing. So originally, it was a test for interoperability. It became a way of testing whether a transport stream was valid, whether all of the parameters, all of the many things like intervals, section gaps, the tables, all of that stuff had to be tested, and it all had to be proven to be in the standards. And ETSI TR 101-290 provided that standard. And it became, as well as being used as an interoperability test, it also became used. Was used then to actually look at transport streams and to fault find them. And it is still, even now, the standard for testing transport streams. All these, crikey, 28 years later, still around. And all Bridgetech probes will implement the ETR 290. I'm going to call it ETR 290 from now on. The VB440, the uncompressed probe, the uncompressed video over IP, that doesn't, because ETR 290 is only applicable to transport streams, MPEG compressed transport streams. So errors are assigned a priority depending on severity, priority 1, priority 2 and priority 3. So a non-compliant transport stream may still work despite it having errors. And this is very important to remember this, because when we look at transport streams now, particularly now, 28 years later, there's been improvements in the technology, things like buffering, the actual quality of the silicon has improved, and set-top boxes in particular and professional IRDs have become far more resilient to some ETR 290 errors. So we aren't necessarily looking for everything being green. We're looking, again, as we said last week, for IP, we're looking for a green screen so long as everything still works. So the The benchmark is this transport stream working? Can it be decoded by my customers with their set-top boxes at home? And if it can, then that stream works. It may not be necessarily ETR 290 compliant, but that doesn't matter. We'll come on to that later. So ETR 290 was in the days of ASI, and ASI was an asynchronous single cable, if you like. The packets would flow asynchronously down a wire, and once they started, they carried on going to wherever they were going. IP, of course, now we transport MPEG packets over IP. That's a lot less well, it's completely it's not as deterministic as an ASI cable going from A to B. IP packets may go via different routers, they may go via different routes, they may be held up on their journey, they may have jitter. So some tests over IP for the MPEG transport stream are no longer valid. Or if they are valid, they have to be taken with a pinch of salt, and you have to read into them what's actually going on. So Bridgetech probes allow users to customize thresholds, and you know that we do this for all of our alarms. Every single alarm that appears on a Bridgetech probe and the VBC is mediated through a threshold. Users always have the ability to adjust these thresholds for their own local conditions. And this, as I said last week and the week before, this is very important. The ability to completely customize your alarms is one of the reasons that Bridgetech probes are so powerful. Some of our competition don't allow priority 3 testing, and they will say, well, you don't need priority 3 testing. No one tests priority 3, or no one thinks that ETR priority 3 tests are important. And, you know, to a large extent, that may well be true. And if you look at the default Bridgetech threshold, in fact, all priority 3 tests are in fact ignored. Nevertheless, Bridgetech gives you the ability to switch those tests on and off as you want. So with the VB120 and the 220 and the Nomad, you can license up to 50 ETR engines in blocks of 25. That's called the bulk ETR option. So all of the 1 gig probes can have a maximum of 50 ETR engines. The VB330 10 gig probe can be licensed up to 400 ETR engines. That's a lot of processing. That's a lot of discrete 24/7 monitoring for those IP streams and MPEG streams. And the thing to know about an ETR engine is it may test one multicast stream continuously, or a satellite channel, or a cable channel continuously. Or you may set that ETR engine to test multiple multicast streams or multiple satellite transponders by retuning. And that means that any of these streams, whether they're multicast streams or RF channels, they spend some of the time not being tested. And of course, it goes without saying that if a multicast or an RF channel is not currently in the engine and it sees some errors, then the probe will not be able to detect those errors. And that makes sense. So you have to trade off reliability. How often do you want to test your ETR 290 tests? Do you want to do them 24/7? Is your stream so important that you need to do it 24/7? Or can you afford to maybe let maybe half a dozen streams share one engine? Because the chances of you catching an error are less and less these days, because transport streams are far more robust. There is an instance where you absolutely must have a single ETR engine, and that's using the Gold TS, and we'll look at that later. Of course, what we do see is, I just realised that is in my view. when you see the micro ETR, which is the so-called overview view, you allow many ETR engines to all be displayed on the same page. And this gives a very dense page for engineers and technicians to view, because they can easily see red alarm boxes easily, even though there may be maybe 80 or 100 ETR engines on one page. It's very easy to spot an ETR stream in error. So let's see some of the detail. We're actually going to move on to, that's it, it's the end of that particular. So we're going to move on to our live. Oh, here we go. So an ETR priority 1 test will probably cause video and audio to fail. So things like unable to pair the audio with the video because the PAT or the PMT are not working, or they're not coming at the right repetition rate. And so these will often cause a set-top box to fail. Remember, this is all about the set-top box at the other end. ETR priority 2 tests, they're less serious. They may cause failures like lip sync errors, but you will get a picture and you will get audio, and you'll be able to change channels and stuff like that. And ETR priority 3 are the least important tests, if you like, if you want to call them important. These may cause problems like EPG. So you might not be able to get your present following information or 7-day EPG. You might not be able to tune accurately between bouquets, for example, stuff like that. So the priority ones are the most serious, and they're the ones we test the most, of course. Nevertheless, you can set up your probe to test all priority 1, 2 and 3. And this is what the micro ETR looks like. It's fairly simple. Priority 1 is on the left, priority 2 is the next column, priority 3 is the next column. And then we have some other checks that have been added by Bridgetech. Now, they're not part of the ETSI standard, or the ETSI suite rather. They've just been added because it's very convenient for Bridgetech to do the testing and then put it into the micro ETR so that you can see these tests. Things like PID checks. Are all my PIDs there? Are the PIDs I expect? Are my services there? Things like service checks. Did the service name change? Did the SID change? And then interface checks. Interface checks, depending on which interface we're looking at. If we're looking at IP, we get 2 tests. If we're looking at, say, satellite, then there are multiple tests. Things like signal to noise ratio, bit error rate, signal level, and so on and so forth. So although these last 2 are not part of the ETR 290 suite, they've been tacked on at the end because they're very, very useful and easy to see. You can see a green means test passed, no problem. Red means a test has failed. It's a binary. It either passes or it fails. There's no warning thresholds like there are for the IP jitter, for example. It just fails. White means a test is currently in progress. In other words, it's still going through the ETR engine. And anything that's grey is a test that is ignored. In other words, we've taken that test out by using the threshold. Right, I'll come back to SCSI 35 later. So now that's the end of that. So we stop sharing that, and I'm going to share my web browser as we go and actually look at, where are we? Oops, sorry, my recorder's just stopped. Can I just need to restart it again. I'm going to have fun editing this week's. So where is my screen edit? There we go. Just starting the recording. Okay, so I've got various probes lined up here. We've got a satellite probe. I believe I've got a VB330, and I've got another satellite probe where we're running Gold TS. So we'll look through these and we'll start with the satellite probe. As you can see, it's a VB220 with two VB272 cards, and we've got a total of 4 satellite inputs. If you look at SAT1, I've got a red bulb here. The red bulb is telling me that something has gone wrong with SAT1 input. So I think we're looking at SAT2. Yeah. Anyway, what we're looking at today, of course, is ETR 290. So the first view that you get when you look at the ETR 290 overview is, first of all, on the left, you always get the Ethernet. So in other words, the multicasts. So all of the multicasts that have got the ETR testing assigned will appear on the left. And then you have the RF, then the next in line would be the ASI input. But the ASI on this probe is disabled. We've turned it off. And then we have the 2 RF cards in the middle slot. And then we have the RF card with 2 inputs in the middle slot. And then the RF card with 2 inputs in the rightmost slot. So they appear in this probe as SAT 1, 2, 3 and 4. And we can show any of these individually by just clicking on show inputs. Or we can just show SAT2, for example. If we've got a lot of micro ETR engines, then this makes a lot of sense. So I'm just going to remind you about the Ethernets, because I'm going to go to streams and I'm going to just look at the 3 multicasts that we've joined, and I'm going to edit one of them. And I'm going to click on ETR 290. Now, when you add a new multicast, this is just a reminder from last week, when you add a new multicast, it is disabled by default. You must come here and enable it. And then you select the ETR engine. Now, this particular probe has got 25 ETR engines licensed. So I could have picked any one of 25. But I picked one because I want to show you round robin. So apply changes and close. When we go back and we look at all of the inputs, you notice that those 25 ETR engines are only applicable to the Ethernet. In other words, the multicast that we're currently tuned to. As soon as you put a satellite card in, or a cable card, or an ASI card, they automatically have 1 ETR engine per input. And that makes sense if you think about it, because the input has got 1 satellite demodulator, so it can only tune, each input can only tune to 1 transponder at the same time, or 1 COFDM channel at the same time. So it makes sense only to have 1 ETR engine, because you can only test 1 stream at a time. Ethernets, of course, we can have, on a VB220, we can have up to 260 Ethernets. So if you have filled up your Ethernets, 260 multicasts, and remember the maximum number of ETR engines is 50, you have to make a decision about how you allocate your multicast to ETR engines. There's got to be some doubling up, some round robin. Maybe you decide that you only test maybe 100, 2 in each engine, and the other 160, I'm not bothered about them too much because they're not hugely important. I mean, they're important, of course they're important, but they don't need ETR testing. Many people don't do ETR testing. So you notice that on the left you can see this little clock going round. This clock is going around, and this is telling me how much time this particular stream, which is called MPTS, this particular multicast, is spending in the ETR engine. And what will happen is, of course, it will finally close that clock. It's currently set at 70 seconds, although you can change that if you want. You can change that. For an SPTS, we would recommend something like 20 seconds. 20 seconds is more than enough to test a multicast SPTS. But the default value is 70. So this is coming up to finishing the test for that 70 seconds. And once it closes, you'll see that it moves on to the SCS and starts again. So now MPTS, the MPTS stream here, is no longer being tested. If we see an error, or rather, if an error comes along in the MPTS transport stream, we will not see it, nor will we see any errors that occur in the TV Norge transport stream. That's just the way it is. Now, if we've got a problem with SES and I need to investigate it a bit further, and I don't want it wandering down to TV Norge in 30 seconds, I can just click in the middle under the lock column, and a little padlock appears. Now this will lock this stream into the ETR engine, and that's perfect for doing some detailed fault analysis. The downside, of course, is that MPTS and TV Norge won't be tested at all now. We're constantly testing SES. Now, just a quick diversion, you can go to the setup screen and you can go to the ETR screen, and you can allow unauthorized users to lock. So basically we can say limit that to say 30 minutes. So after 30 minutes, that lock will automatically spring open. So you can do that, and it's a very good idea to do that, so that you don't get an engineer at the end of his shift on Friday going home, leaving the ETR locked and no testing is done on the other streams all weekend. You know, that can happen, and you might see some errors over the weekend that no one spots. Anyway, so you can do that. While we're on this a particular page, it is possible to download private descriptors, and you will be able to edit these here. And if you want to download your private descriptors, then this is how you would do it. So they're different for different streams, of course. So depending on the tag, that would determine which descriptor. So it's possible to do those. Sorry, they're the parsing rules you download elsewhere. And if you are looking at ETR RF mode, when you're looking in the RF, you can change the units. So dB microvolts, dB millivolts, for example. And you can your naming convention. So there are various things here. I'm not going to go into this in detail. Check out the manual for this. So let's go back to the ETR 290. You can see it's still locked. So I'm going to put this out of its misery and unlock it. Let's look at TV Norge. You'll see they sort of go white and then they go green as they check. Now look at this. Half of this, certainly all of priority 3 and half of priority 2 are grey. That means we've scheduled we haven't scheduled anything, I do apologise. We've used the threshold to ignore these tests. And if we look over on the right hand side, you can see the ETR threshold that's being used here, and it says default. I'm going to lock it just here. You can see I can lock it on this screen as well. In fact, you can lock it on all of the tabs. So the ETR threshold is the default threshold. So what's this mean? This means that whenever I apply the default threshold, which gets applied by default, that's the clues in the name, then I won't be testing priority 3. I won't be testing half of priority 2. And I'll even be not testing priority 1, missing PID. Why? Well, there are many reasons. As I've already sort of alluded to at the beginning, that the kit has got far more robust, better silicon, much faster silicon. That's one of the key factors. Bigger buffers, and so a lot of these things like PCR accuracy, they will be dealt with in the set-top box ultimately. Things like this, the event information table, time and date table, these sorts of things, you can test them if you want, but we have analysed the failures over several years, and we find that these are very often don't involve problems that cause problems to set-top boxes. SI repetition rate and unreferenced PIDs, well, we see these errors all the time. People seem, broadcasters particularly, seem very cavalier in the way they put together their transport streams now. You'll see missing PIDs all the time. So you'll get missing PID alarms all the time, and the broadcasters are quite happy for their transport streams to go out with missing PIDs. They come and go, maybe they're audio channels or teletext or something like that, private data. They come and go, and the broadcasters don't seem to be bothered too much about repairing or making the transport stream SI and PSI show exactly what's in the TS. Now we'll come to this when we look at Gold TS later. So we've turned off all of these. And if you're looking at an MPEG transport stream that's being carried by a multicast, particularly an SPTS, which most multicasts are in a head-end system, then you'll see maybe 5 or 6 or 7 or 8 PIDs in this transport stream. So things like, it won't have a NIT, it won't have an EIT probably. It may not even have an SDT. So there's no point testing these. It certainly won't have a TDT. So there's no point testing these. So we turn them off in the default. And remember, MPEG transport stream over IP. IP is bursty. The old days of ASI, asynchronous, one packet followed the other very, very regularly, unless there was a problem, of course. And so things like PCR accuracy they still are important, but they were much easier to check. An IP multicast is bursty. So testing things like PCR accuracy, PCR jitter, presentation timestamp, they're much trickier. And so we tend to turn them off. You can turn them back on again if you want, but you'll see errors all over the place, particularly with multicasts. While I'm here, we've got an alarm graph that a lot of people don't even know exists. We can click on the alarm graph. And there's not much to show on that one because this is round robin. This is a round robin thing. But let's go to, say, satellite 2. So I can conveniently move backwards and forwards between my ETR engines effectively by just clicking on one of these buttons at the top. Now there's a lot going on here. For a start, we have all of our priority 1, 2 and 3 tests enabled. And we are seeing some errors. Now let's look at the show alarm graph, and we can click and disclose these, and we can actually see where our errors are and when they occurred. So we've got a nice little graph there showing that our errors happened on our PAT and our continuity. Missing PID is entirely is continuous, but we had a CRC check, we had a CAT error here. And we said we had it between 1815 and 1900 yesterday. That's quite nice to know. That could be significant. Notice that we can only show 24 hours. Unlike the multicasts themselves, which we can go to 4 days, the ETR alarm graphs only show 24 hours, or maximum of 24 hours. And of course, if you're showing round robin stuff on if you're doing a lot of round robin, then this will have lots of gaps in it, of course, because if you've got 4 multicasts sharing one, if you have 4 multicasts sharing one ETR engine, then for 3/4 of the time they're not going to be tested, and only 1/4 of the time will they be tested. So you have to bear that in mind when you look at these graphs and errors. The other nice thing about this detailed view is the ability to actually see what's missing. So you click on the error and up comes the missing PID. The missing PID is 4105. Can't even read it. Let's look at something in a bit more detail. The event information table. So the presence check. So the PMT is signaling an EIT, but it's not there. So we can see that we are getting no EIT. So all of the other errors are in fact invalid. Let's see if we've got a little bit more CAT error. Repetition. So this error is a repetition check. So you can see that the limit is 500 milliseconds, and the maximum interval is 509 milliseconds. So this error is just only just an error, 9 milliseconds over the standard. And that's one of the problems with ETR 290 testing. They ETSI laid out, they had to draw a line somewhere, of course, and they say that the cap must appear every half second, every 500 milliseconds. And if something is even 1 millisecond over, then that will generate an error. So what do? Do you stop testing the cat? Because the cat can be quite important. Well, it is quite important if you're scrambling. So the conditional access table, maybe you can just tweak the threshold. Make the threshold, instead of 500 milliseconds, make it 550 milliseconds or 520, something like that. Well, the thresholds allow you to do that. So you no longer have a transport stream that is completely in spec, but you're not generating any errors, because at the end of the day, the set-top box is still fine. It's descrambling this service without any problem. 9 milliseconds isn't going to stop the set-top box from working, generally speaking. So let's adjust the threshold to take that into account. And now we've got a nice, then at that point, we will have a nice green. We will have a nice green display with no errors. I want to go back to the Ethernet, because it's interesting that a lot of these are grey. But they still say an error. They're still showing an error. And that's quite important to know, because even though the threshold is saying ignore this error, that's exactly what it's saying. Ignore the error. It's not saying don't test it. It's just saying ignore it. Don't use this data to generate any alarms, which will then go forward to the VBC. Excuse me a second. Okay, sorry about that. So we can still interrogate this even though we're not generating any alarms. So I can look at the event information table, and sure enough, it's not there. So we do these tests. The tests are still, the ETR engine is still carrying out the test, and I can still interrogate it, but it's just not generating an alarm. So we've seen the ETR details, and we can see that we can nicely move backwards and forwards between the different interfaces that are being checked. Notice, of course, that we are getting some RF checks and RF alarms. Again, the threshold, the RF threshold this time, not the ETR threshold, but the RF threshold, allows me to make changes. I'm not going to deal with this today because it will be dealt with tomorrow, but we can still see exactly very, very detailed error information. 10 to the minus 6, we're seeing 10 to the minus 3. Sorry, we should be 10 to the minus 3, we're seeing 10 to the minus 6. So this gives you the ability to interrogate these alarms. Notice that this particular SAT3 is using a different threshold. It's not using the default threshold. It's using the ETSI TR 101290 threshold, which is, sorry, I can't very easily highlight this. Damn. So the ETSI TR 101290 threshold is a complete test of everything. So now let's just traverse this a bit and see what some of the other information is showing us. So we're saying PIDs, we can still lock here. We can still lock. Now this particular SAT3, if we look at SAT3 just quickly, we'll see that there is only one, there's only one frequency enabled. So it is by default sort of doing a lock. It's being locked into the ETR engine because it's not the demodulator is not trying to tune to any other frequency. Again, we'll deal with that all next week when we look at RF. So we were looking at PIDs and we were looking at SAT3. So we can see things like CC errors. Very useful to know. Have we got any CC errors? None in this. Now you'll see more CC errors on the Ethernet multicasts and the MPEG transport streams in the Ethernet multicasts. But for now on the satellite, it seems to be pretty good. We've got a little bit of information here. We've got a bit rate and we've got the effective bit rate. It's 188 bytes, so not 204, but 188 packet length. And there are 131 PIDs in this particular transport stream. And we can go up and down this and look at all of the individual PIDs if we want. We can sort on PID numbers, bit rates, by clicking, as I've mentioned before in the past, by clicking on any of these column tops, we can sort on that particular column. And there's, of course, we can actually look at more information if we want to. So it gives us some references. What is this PID actually doing? What is it referenced to in this transport stream? So, quite useful. Services, so everything's now service-based in the service view. So we can click on the services and we can get a table that gives us a tabular view of the services in this particular transport stream. So there's quite a lot in this particular transport stream. Remember, 131 PIDs. We've got a lot of radio here, as you can see down the bottom. A lot of radio services. Doesn't even fit on the page. But we do also have quite a few high definition streams as well. So we can look at these in more detail. Now there are a couple of things I want to show you here. First of all, that's all the components in this particular service. We've got the video, we've got the audio, we've got AAC audio and AC3, we've got some subtitling, and we've got some DSM. So we've got some, what's that to do with? It's to do with the encryption, the scrambling. Now, what I want you to notice is, firstly, I want you to notice that the video and audio PIDs are coloured, and now they're coloured blue, but before they were coloured green. And this gives me an instant view that these PIDs are scrambled. So if they're blue or green, they are scrambled. Now, the reason that they're changing colour is because of the this is the so-called crypto key, the crypto period. Generally speaking, it's 10 seconds. And this is 10 seconds and then the crypto key changes. So it's constantly changing the key. And it changes every 10 seconds. And it uses an odd key and an even key. Now, I don't know which one's which. I can't remember whether the green is odd or green is even. But basically, this tells me that these PIDs are scrambled. And it tells me that the odd and even keying is working. So straight by seeing that, I can see that. And also notice that 1065, the PID number is bold. All the other PIDs are in standard characters, but the video PID has the video PID is in bold, and bold means that is carrying the PCR. So so it's showing me that, and it tells me carrying the PCR, and it says yes. We'll come to the histogram later. So it would enable me to show normally, if this was unscrambled, I could actually decode a thumbnail. I could decode a thumbnail and I could be checking on the audio. But of course this is scrambled, so we're not going to be able to see anything. But I can still see information about I can still see some information about the stream. But you could have seen that in the previous view anyway. So if we were unscrambled, I think everything in this is unscrambled. Is scrambled? Yes, it is. So it's all scrambled. So I can't decode any of these into a thumbnail. But if it were in the clear, just click on thumbnail and it will show you a thumbnail and audio bars. Bit rates, well, this bit rate can be quite useful because it can show you a minimum maximum bit rate in numbers in the table, but it can also show you that as a graph. So you can see if a particular video might be a very low bit rate, and you can see it as a graph. And if I expand these, I can actually show the component bit rates as well. And this could be quite useful in fault finding if you've got some transport stream or services that aren't behaving as they should be. You can actually see you can see them. You can reset. You can actually no, you can't. I thought you could reset. You can reset these numbers so they go back to 0 and start again. But you can't. But I can show only the PIDs. So I could actually show my again via PIDs, and obviously they're the video PIDs. We can see those quite easily. Notice they're all green except for the bottom one, and now they're all blue except for the bottom one. So there's another view of the scrambling and the odd and even keying. And if I want to, I don't know how. Are there any null PIDs? Yeah, there is some null PIDs. In fact, they're 1.1 megabits. So I can do exactly the same, but not show the null. So the null PID disappears. So the stuffing PID 1FFF is gone. Tables. Tables useful. Again, you want to be able to see the tables, so we can actually show the PMT. We can show it in English. In a tabular form, we can show the conditional access table in tabular form. We can even show I'll come to the EPG in a minute. Sorry, the EIT. So we can show the program map table. Again, we can do all of this in tabular form, which is nice, but we can also show it in hexadecimal. So we can be showing, like, if I want to know the section number, then there is the section number. If I want to look at the PCR PID, then there is the PCR PID. So again, this could be useful in some very detailed fault finding. If you're trying to troubleshoot some complex MPEG problems, then this is another way of doing it. And you can even, by using this button here, I can download a binary file. I can download these tables as a binary file, so I can even use these for offline analysis. Let me just go back to the EPG. So EPG, I can actually read the EPG in whatever language the EPG is presented. And if I had full 7-day EPG, which I don't on this particular transport stream, I do have one somewhere that has got one. I can't remember which one it is. It's not that one, obviously. No, maybe it's SAT2. Oh, while I'm looking at SAT2, I think this one hasn't got any. Oh no, must have been SAT. It was SAT4. No, they're encrypted. Oh, okay. This one isn't encrypted. Let's have a quick look. See whether we can decode a thumbnail on this. Should be able to decode a thumbnail, but I'm not seeing one. Not sure why. It was working yesterday when I set this up. Never mind. Yeah, so what I wanted to show you was full EPG, but I can't see any full EPG. So, but anyway, you click on there and it bring up the 7-day EPG. Again, as a table. Go back to SAT3. So PCR. Now, PCR is still important when you're looking at things like satellite, in fact, any RF delivery, even ASI. So PCR is quite important. So it's nice to be able to measure the PCR jitter, and I can select any PCR from this transport stream. And okay, that's probably one of the radio channels. It is one of the radio channels. So again, I can draw a nice graph of my PCR, and as you can see, that's well within the plus or minus 500 nanoseconds limits. I can turn to the OJ measurement if I want, but it's disabled anyway. So, but if you enable it, that's where you'd see it. Let's go back to AC. So clear, and I can clear it and start again. So I can start my counter at 0, start again. T2MI we'll look at when we do terrestrial. Status. Now basically status is another view. It's a very simple view. It's basically a view on the service. Well, in fact it's both, because it enables me to look at the service view and the PID view. So basically I can look at any alarm on a service basis, or a service by service basis, or I can look at any alarm on a PID by PID basis. And that would tell me, it's basically just another view. And it's telling me I've got a section repetition check. And if you remember, that's exactly what we saw when we saw the ETR details. So this gives you a very quick way of homing in on a particular error. Let me just close that and open it again. So I could actually see that we are seeing some unreferenced PIDs. Now compare gives you the ability to select 2 or more streams, or 2 or more services in a transport stream. So let's look at, say, that this is on the probe, by the way. So we are looking at an MPEG transport stream in the Ethernet. In fact, we're looking at 3, of course. And we're looking at the SAT 1, 2, 3 and 4. So I can compare. So say, for example, I had a transport stream that was coming in from an IRD and another one that was coming out of a MUX, and they needed to be the same, or I needed to be able to compare them because they're in 2 different stages of the head end. So I could do that here quite easily by selecting. So this isn't going to work because they're different, but I can select that with control click and then compare selected. And now this will bring me up the full ETR 290. No, that wasn't a very clever one to choose, was it? Because there's nothing in it. So let's just select these 2. So now I can actually look at, first of all, I can see the number of errors over, and these are error seconds. We talked about error seconds 2 weeks ago. The number of seconds that have an error. So you can see the clock faces tell you the number of, the amount of time there have been errors. So some of these very small amount of time, some others like 66% of the time has been an error. And then you can go down here and actually look at the errors. You can compare them side by side if you want to. So we can see that we've had these are different errors. They're different errors on different times. But this gives you the ability, and if you make the screen smaller, the web browser smaller, then you can get 3 or 4 on here quite easily. And then all the way down to the actual detailed ETR view. So that's quite a useful little trick there to be able to compare on the same probe different ETR 290 monitor engines. ETR thresholds, well, we'll take a quick look at the thresholds. Again, we've got 14 thresholds. I think the maximum is 50 different thresholds. I think there are 6 default thresholds. And we've got multiple thresholds here. Default threshold, if you look at that number, 136, that means 136 streams or multicast streams or RF channels are referencing this default threshold. And if we look at the ETSI TR 101290, the complete test, then there are 4 streams stroke RF channels referencing, using this as a test. Now we look over here and you can see tuning duration, 70 seconds, 70 seconds, 40 seconds. 20 seconds down here for the IP SPTS. So if you're looking at an IP SPTS, it's a good idea to use maybe the IP SPTS threshold as a starting point. Remember, the thresholds are always, the default thresholds are always the starting point, because you'll always want to just tweak them ever so slightly. So you'll copy them, you'll duplicate them, give them a new name, and then tweak them. Remember we said we might want to change that, what was it, the cat. Let's go back to the default. But we can't change the default, of course, but I can show you how it works. So we came to the cat, and it was a priority 2 alarm, and there's the alarm, and it's currently alarmed, and there's the 500 milliseconds. So yeah, I can change that to 550 milliseconds, and that alarm will disappear. So yeah, I can do that for all of my tables. And you can see it starts with the DVB tables, service descriptor table, event information table, and then it goes to the ATSC tables. So again, it works with both. Then we've got those other checks. Remember the other checks, the Bridgetech checks? Well, some of those are additional CA checks. You can change the ECM, the entitlement control message, and the entitlement management message. You can change the duration of those, and you can set up alarms for bit rates. Then you can do things like PID, minimum maximum bit rates. We'll look at these when we do the hidden features on the probe. And service checks, again, we can allow those. We can cause them service checks, we can disable them, or we can make them alarmed. The mega insertion inspection package, insertion package, I can never remember what that stands for. But again, we'll deal with that when we look at terrestrial. Gold TS, we'll look at that in a minute. We'll come back to that. Content checking is where you allow the probe to decode 1, possibly 2 thumbnails, and then do a content check like freeze frame. In fact, it is just freeze frame. We talked about that back on session 1. We can do content checks and we can turn them on. Yeah, it's a licensable feature, but you can only do 1 or 2. The probe doesn't have the oomph, if you like, to be able to do that. So we select on the Gold TS, we'll come back to that in a minute. Time information check. Well, we can do some time information checks. So things like enable or disable alarming if there are errors. These are all in the manual, by the way, the user guide. Time information check, so we can check the time in the top table and alarm if it's wrong. Of course, we need to be connected to NTP, because NTP is the sort of gold standard, if you like, usually. As long as you set your time zone up right and offset. And so you can check the transport stream's time, the time and date table. You can check that information against the NTP. So that's a useful additional check. Not part of ETSI TR 101290, just something additional added by Bridge Technologies. And then, of course, this is where you turn on your RF checks. PID and service thresholds, will come up to those later when we look at the probe hidden services, hidden features, really. Okay, so now we're just going to look at Gold TS. So we're going to look at Gold TS, and I'm going to show you that on this probe. But before we do that, I'm going to stop sharing the, where are we? I'm going to stop sharing this because I've just got a couple of slides to show you. We've got about 5 minutes to go. Where are we? Yeah, here we go. Stop sharing. Stop sharing. Stop sharing, and let's share my screen to Keynote. Oh, where is it? Okay, I'm not going to make these full screen because I'm just going to show them to you. Oops, except I clicked the wrong window. So Gold TS reference. zip through this really quickly. Monitor subtle changes on any TS. So these are changes to a transport stream that will not be picked up, generally speaking, by ETR testing. Can be used on any MPEG transport stream. Doesn't matter whether it comes from an Ethernet multicast or from a satellite. It does require a dedicated ETR 290 engine because it makes sense. If you think about it, if you want to check a transport stream to see whether it changes, then you need to test it 24/7. So, and I've said this before, it's a great, if people are interested in Gold TS, it doesn't cost anything. It's an option. It's not an option. It's a standard feature. But what it does do is it drives the customer to want to buy additional ETR engine. So it's a great sales tool for generating bulk ETR testing, bulk ETR upgrades. So it's really nice for that. So changes to a transport stream are not illegal. A lot of them aren't illegal, and they can't be found with ETR testing. So they'll make operators, we've already talked about this just now, they'll make changes to service lineups and they don't tell anyone downstream. They don't really properly necessarily reformat the PSI and SI. So sometimes an operator won't notice anything, particularly if it doesn't generate an alarm, and they'll get a call from someone saying, oh, my language has changed or whatever, something's happened. So Gold TS will allow a transport stream to be continually monitored for any changes. It takes a snapshot of a transport stream. So basically you say you establish to yourself that the transport stream you are receiving is the gold standard. It is exactly right. So you take a snapshot of that and you use that snapshot to measure the incoming transport stream against. And you do that 24/7. So you have a reference stream and you have the incoming stream, and they're continuously being tested. Any change will be noted. It comes up in red. I'll show you this in a minute because I've actually got it working, and you'll see it. We'll see this actually in live, and it can be used anywhere in the downlink. Mainly, it's often in downlinks, but it can be used anywhere. Anywhere there's an MPEG transport stream that needs to be monitored. So we'll quit that for now. So let's quit. Go back to the. Actually, before we do that, I just want to show you ETSI SCT35. So I will continue to share just for a moment. Because it would save me having to go back again. So SCT35 or SCTI-35, some people call it, signaling that's inserted in the transport stream, and it's used to control downstream devices like vision switchers, vision mixers, play-out devices for playing local adverts and stuff like that. So it's used quite a lot, regional opt-outs, all of that sort of stuff. So this is an optional extra. Needs to be purchased to work on a probe, and you will need to assign an ETR engine to it, a dedicated ETR engine, but basically it will monitor the transport stream and it will log any SCTI-35 event that appears in the transport stream, and it can be interrogated by clicking through. So a lot of details there. No alarms generated because the probe doesn't know whether there should or shouldn't be a SCTI-35 marker. It doesn't know that there should be one, but if one comes along, it will be logged. So an operator can go back to his schedule and say, yeah, there should have been one at 20, 35 and 40 seconds, and he can look at the probe and say, well, there definitely wasn't one in the transport stream because it's not here. So that's how SCTI-35 works. Very useful for those people who use it. So now let's go back to sharing, and we'll just cap that up in the last 5 minutes as we share back to our Chrome. I can't see it at the moment. So let me just get Chrome up and running. Oh, where's it gone? Where's the other window gone? There we are. Okay, so Gold TS. So basically we go to the Gold TS tab. Remember, this is a standard feature. It's not a licensable option. You don't need to license, it's there. So we add, so we select a threshold. So let's say now, which MPEG transport stream do I need to monitor? In fact, before I do that, let me go back, because there's one of those, oh no, so it's just that one. We've only got that one. Never mind. So let me select a threshold. So I can select all of my ETR engines. Oh God, 400. That was a bad choice, wasn't it? Let's go to my, this is much better. Okay, so now I've got satellite probes, so I can select an ASI input, I can select any of my satellite inputs or any of my Ethernet, ETR 290 Ethernet engines. So basically I can select any transport stream. So I select SAT4 and I just basically generate a threshold. It's as simple as that. And what happens is SAT4 is added to the bottom of the list. And if you look, it says one reference. So if we go to SAT4 and we look at the tuning setup, we can see it's been added. And if I just edit that quickly, you can see the reference table set has been selected automatically. I don't need to do anything else. However, what I do need to do is I do need to go and turn it on. So if I've selected the threshold for the MPEG transport stream, I need to turn it on in the ETR threshold, because remember, it has to be turned on. So if I look at one of these at random and go down to Gold TS, Gold TS is currently disabled. So I need to create an ETR threshold that has Gold TS enabled. And then I select which tables I want to monitor. So basically I'd monitor them all. I can even monitor the CRC, the cyclic redundancy check, and the version number. So I can check that, make sure there are no mistakes there as well. And there away we go. And what happens is we go, but now we can go back to the probe and look. Again, that wasn't the best one to pick. Goodness me. It's all changed since yesterday. Damn. Gold TS is not there. So where is my Gold TS? Be with you in a second. It's not on any of those. It's got to be on this one, isn't it? There it is. Yeah, there it is. No, it's been turned off. Gold TS has been turned off. Damn. Someone's changed this since I worked on this yesterday. Now, what would happen would be that you would get. I really don't understand why that's gone. Anyway, well, if you review the video, you'll go back and you'll see what happens is you'll get an error and it will come up and it will tell you that the reference table will be on the left and the table in error will be on the right, and the areas that are wrong, that are changed, will actually be in red. So you just click through and it will tell you exactly what's happened. It will tell you exactly where the change is. So for example, something simple like a language descriptor. A language descriptor, on the slides, if you look, you'll see that the language descriptor changed from Norwegian to German. There's no way ETR 290 would pick that up. But the Gold TS does, because it knows it should be Norwegian, but it detected German as a language descriptor. It's a very subtle change. And it spots it straight away, generates an alarm, raises an alarm, and it's there to be interrogated just by clicking it. I'm sorry it's not there, because it was there this morning. Anyway, now SCT35, I've got the same problems with SCT35 because you can see it's there, it's licensed, but there are no logged events. So there's nothing actually come up in the logged events. However, it's quite an interesting learning opportunity because I can go back to ETR details and I can look at this stream. This is the stream that has the events, or should have the events. And if we look at missing PIDs, remember we said missing PIDs is not going to generate an alarm because it's not part of the default threshold. But I can see there are errors. So it's not generating alarm, but I can still see there are errors. And what do you know but the two SCT35 PIDs are missing. So that's the reason we don't have any logged SCTI-35 events, because our PIDs are missing. So that would immediately give me something to go back to. Anyway, so that's how this works. So that's sort of ETR. There's more about ETR in the manual. I've already gone on for an hour and 10 minutes, so longer than I hoped. These always seem to drag on for an hour. Not drag on, but they seem to go on for an hour because there's quite a lot to discuss. So, ETR 290, remember the default thresholds don't test priority 3 and they only test partially priority 2, but you can turn these all on. Tell your customers, well, maybe you don't need to test ETR priority 3 now, but you might want to in the future for all sorts of reasons. So again, it's a selling point. It's a selling point that we don't tell, like some of our competitors, we don't tell customers they can't test priority 3. We tell them that they won't default, but they can if they want to. And that's the same with all of our thresholds. So I'm going to draw this to a close now, gentlemen, and thank you very much for listening. Remember to take the quiz. I will be sending out an email to everybody, people who are here today, people who weren't here, with details on where to watch the video and where to see the test and what's coming next week. So next week, I can tell you, I think I've already mentioned it 3 or 4 times, it's configuring and monitoring RF. So thanks very much for your time, and I'm going to stop sharing and I'm going to call an end to that. So thank you very much indeed, gents, and bye for now. See you next week. Thanks, Kenny. Good man. You're one of my loyal watchers and listeners. It's great to see you here. Bye all.